Yo, listen up, here's the story about a little guy that lives in a blue world.
Hi guys, we continue with the shear force and bending moment diagram for overhanging beam. By using the three equilibrium equations, the unknowns VA and VC can be determined.
And everybody around, 'cause he ain't got nobody to listen. I'm blue, I've been deed, I've been died, 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 I've been deed, I've been died. I'm blue, I've been deed, I've been died, 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 I've been deed, I've been died.
Now we proceed with shear force diagram. There are several approaches that I will show you in this example. So we start with approach number 1 by calculate the shear at each point. The points are selected based on the material interruption or system interruption such as support or the loading interruption. Each interruption point will have two values before and just after the point. The sign convention for shear is downwards positive when we move from left to the right of the beam. Otherwise, you can also choose upwards positive when you move the calculation from right to the left of the beam. So let's start with Q1 at point A. Q1 is located just after point A. Here we have a vertical reaction at support A upwards. Therefore, the equation is Q1 minus 7 equals to 0, and the result of the shear values at A is positive 7. Analog to Q1, we calculate further for Q2 until Q7. We mark and write the values of shear in the diagram, but the shear line behaviors will follow the integration of loadings. Example, for constant loading, which is an uniformly distributed load in segment CD, will produce a linear shear line of segment CD. The second approach is by using the shear equations for each segment. We need to identify the origin and the range of X for each segment. For example, for segment AB, we select the point A as an origin. Therefore, the range X is from 0 to 3. The direction of the positive shear is still the same as in previous approach, so we get Qx equals 7 for segment AB. For segment BC, we select the point A as the origin, so the range of X is from 3 to 5. We can also select point B as an origin, but the range of X will be 0 to 2. For segment BC with origin A, we get the shear equation Qx equals to negative 10 times x minus 3 minus 23. And for segment CD, we get QX equals to 10x. We substitute all the x values in the shear equation with the range of x values of each segment. For each segment, we draw the shear diagram. The shear line behaviors will follow the higher order of x in shear equation. Example, for segment AB, we have the equation Qx equals to 7, which is a constant line. Segment BC, we have x power of 1 in the shear equation, so the shear line is linear, as well as for segment CD.
And everything is blue for him and himself and everybody around, cause he ain't got nobody to listen. I'm blue, I'm a need, I'm a die, 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 I'm a need, I'm a die. I'm blue, I'm a need, I'm a die, 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 I'm a need, I'm a die. I have a blue house with a blue window. Blue is the color of all that I wear. Blue are the streets and all the trees are blue. I have a girlfriend and she is so blue.
For bending moment diagram, we start with approach number 1 to draw a bending moment diagram by using the calculation of interruptions point. The moment is counterclockwise positive when we move the calculation from left to the right of the beam. For this example, the most important interruption points are point B and C, while point A and D are auto support or points, which is normally the moment equals to 0, except there are fixed support or moment point load is acting at that point. We draw a bending moment diagram by referring the shear force diagram because the integration of shear force will produce the bending moment. The value of shear is the gradient of the moment. For segment AB with positive constant shear, will show the positive linear moment after the integration. For segment BC, we will get a moment line as a parabolic with negative gradient because of the negative values of shear. Then the segment CD shows a moment line as parabolic with positive gradient because they are positive shear values. We can also get the moment values by calculating the area of shear in shear force diagram. This method looks like more easier than the first approach.
And everything is blue for him and himself and everybody around, cause he ain't got nobody to listen. I'm blue, I've been deed, I've been died, I've been deed, I've been died, I've been deed, I've been died, I've been deed, I've been died.
The last option for bending moment diagram is by using a moment equation. Normally, this approach is applied parallel with a shear force equation for each segment. The sign convention is the same as in the previous approach. The advantage of this method, we can use a moment equation to get the shear equation by differentiate the moment, and also we can identify the moment line behaviors by the higher order of x in moment equation.
And a blue Corvette, and everything is blue for him and himself and everybody around, cause he ain't got nobody to listen. I'm blue.